And today we're going to continue our conversation about velocity and mechanisms. As you remember, last time we were talking about linear velocity, and today what we want to do is talk about angular velocity. Now, linear is between 2 points in a straight line. This time, we're talking about rotation. We're talking about a point going around a center. It could be a link. It could be some kind of an object that's traveling in a circular motion. So what we want to do is figure out what its speed is. And in order to do that, we have a formula that's very similar to the last formula. Now, as you can see here, this point can rotate one way or the other and should be noted in your answer. And the speed of all the points on the link are the same. So it doesn't matter how close it is to the vertex or to where the pivot is, all these points travel at the same speed. So therefore, when we look at this and we look at our formula, we see it's very similar to the linear velocity formula. So we're using small w for angular. We're using delta theta. This is a symbol for some kind of a rotational unit. And delta t, which is time, as you've seen before. So therefore, if you look at these things here, we have basically the same arrangement as we had for linear, with different units. Now, speaking of units then, there are three possibilities. There are more, but basically these three possibilities are the more familiar ones for kinematics. RPM, as you're all familiar with, is revolutions per minute, degrees per second, and radians per unit of time, like minutes, radians per minute. We will discuss radians in our next topic, so we will leave this for now, and then we'll come back and visit radians the next time. So basically the same thing as we had for linear, it's just that we're going to use rotational. Now, my example is following the same format that we have always used. We start out with our statement, with our givens. The drawing can also be helpful for your givens. And then you write your formula or the tool that you're going to use here. And you make your substitutions. And you get an answer. However, this answer I have there is not the final answer, because if you look at what you had written here to find, we're looking for RPM. This would be fine if I wanted degrees per second. So there's an additional step here that has to be in play. And that additional step is that we're going to have to convert the degrees per second to revolutions per minute. This is the key for being able to work in engineering, is to be able to understand what units you have and what your answer should be. So look, we just start to lay out the problem, and to clearly lay it out, I usually use this method. And for beginning students, this is probably a good way to lay it out. And I would recommend that you do this. So we have 60 degrees per second. I multiply that times 1 revolution per 360 degrees. And this is the conversion factor. And then 60 seconds per 1 minute, which is another conversion factor. So therefore, when I do this operation, and with the units showing, I can conveniently cancel out the units that will cancel through the math process. And what I get left with is revolutions per minute, or RPM. So here's the math. 3600 divided by 360 gives you 100. And your answer then, underline W equals 100 RPM. So follow this example, follow this model, and I think you should not have too much trouble with any of these problems. Okay? Any questions? Let's go to work then.